Okay, let's dive right into this explainer and completely shatter pretty much everything you thought you knew about how your memory works. For the longest time, we've treated human memory like a dusty old filing cabinet, right? Like it's just this biological video recorder where we store past events, and we only open it up when we need to remember where we parked the car or what we had for lunch. But cutting-edge neuroscience is telling us a completely different, and honestly, a mind-blowing story. Your memory isn't just a record of where you've been, it's literally the engine of where you are going.
So, to understand this, we actually need to start with a huge biological mystery. How are humans able to invent, innovate, and constantly create totally new futures unlike any other animal out there? I mean, think about it. If you look at our physical place in the world, we really aren't the strongest, we aren't the fastest, and we're definitely not the most numerous. Insects have us beat by an absolute landslide in sheer numbers alone. Yet we're the ones who have built global civilizations, cured diseases, and literally walked on the moon. What gives us this unparalleled ability to look at our current reality and imagine something completely different?
Well, the answer is hiding right inside our brains. Specifically, in a fascinating process that science, frankly, just misunderstood for decades. Deep inside your brain is this tiny, seahorse-shaped structure called the hippocampus. And for over half a century, the scientific community was absolutely dead certain that the hippocampus was strictly the memory department. If it got damaged, you couldn't form new memories. End of story, right? Actually, scratch that. The plot twist here is wild, because it turns out this structure is actually the biological engine of your imagination.
Let's look at this landmark study from 2007 to see how this flipped the script. Researchers brought in people with amnesia caused by damage to their hippocampus and gave them this exact prompt. They just asked them to visualize a completely fictional scenario, a white sandy beach, a beautiful tropical bay. And shockingly, the patients found it almost impossible to imagine new, logical scenarios. They couldn't construct the scene in their mind's eye at all. Think about the implications of that. If the hippocampus was only for remembering the past, why would damaging it completely destroy your ability to imagine a made-up future? This was a massive, game-changing turning point in neuroscience.
Here's the massive takeaway. The hippocampus isn't just a filing cabinet. It actually uses your memories as the raw materials to actively construct and simulate the future. Let's think of your memories like a giant bin of Lego bricks. The hippocampus doesn't just keep the fully built Lego castle of your past sitting on a shelf. It rips those experiences down into individual bricks, the people, the places, the feelings, and uses them to build entirely new, imaginary structures. It lets you test out what-if scenarios in your head before you ever actually do them in real life. So memory and imagination, they aren't separate systems at all. They are literally two sides of the exact same biological coin.
Now, here's where things get super counterintuitive. You'd probably assume your brain works the absolute hardest when you're laser-focused on a task, right? Well, it turns out that when you just zone out, this amazing thing called the default mode network kicks into gear and syncs up with your hippocampus. In our modern hustle culture world, we kind of feel guilty when we aren't being productive. But when you're just staring out a window or letting your mind wander in the shower, your brain is doing some seriously heavy computational lifting. The default mode network lights up, talks intimately with the hippocampus, grabs those memory Lego bricks, and just starts running these wild, incredibly creative simulations of the future.
To put that into perspective, let's look at the electrical signals in the brain, known as sharp wave ripples. When you're awake and actively engaged in doing something, your brain waves follow a pretty steady rhythm. But during deep rest or sleep, you get these massive, rapid spikes in electrical activity. These ripples are the physical proof of your brain replaying past events at incredibly high speeds, like up to 50 times faster than the actual experience. So zoning out is definitely not a screensaver mode. It's your idle brain working incredibly hard behind the scenes.
And you can actually map this simulation engine working in physical space. Researchers hooked up sensors to rats running through a physical maze. While they were running, their brain cells fired in a very specific sequence to map out the physical space. But during rest, something incredible happened. The resting brain compressed and replayed the exact same physical maze sequences, sure, but it went further. It generated entirely new, completely unexperienced paths. The resting brain was literally simulating new ways to run a maze the rat had never even tried. It's testing out those future what-ifs. This right here is the biological root of planning and innovation.
So, if we pop the hood and look at the actual wiring of this simulation engine, we see that the hippocampus is not just some uniform blob. It is highly organized, sophisticated biological hardware made up of subnetworks with very specific jobs. To understand how we actually pick which imagined future is the right one, we need to zoom in on two very specific areas of this neural wiring, the CA3 and CA1 networks. Okay, think of the CA3 network as your brain's biological VR headset. It's got these massive looping connections that let it just throw a million ideas at the wall and simulate endless future possibilities. It simulates everything. But obviously, if we acted on every crazy scenario our brain cooked up, we'd be in real trouble. Enter CA1. CA1 is your inner critic. It coldly evaluates all those wild CA3 simulations and asks, okay, but will this path actually lead to a reward? Together, this is the simulation selection model. Your brain dreams up the possibilities, picks the absolute best outcome, and then guides your behavior.
So what does this all mean for us? It means daydreaming is absolutely not a bug in your system. This whole neurosimulation process is the core biological foundation of human creativity. Your ability to remember the past was never just about nostalgia. It evolved so you could break your history down, hand those pieces over to your hippocampus, let your default mode network run wild while you rest, and use CA3 and CA1 to simulate a better future. That's your built-in innovation engine. It's the literal reason we can step back from a tough problem and suddenly have a eureka moment out of nowhere.
I want to leave you with a pretty provocative question. If innovation literally requires simulation, when was the last time you gave your brain permission to do absolutely nothing? We live in a world that constantly demands our attention. We scroll on our phones the second we're waiting in line or sitting on a train. But every time we do that, we are starving our default mode network. We're stopping our hippocampus from firing those sharp wave ripples and simulating brilliant new ideas. So, if you want to be more creative, more innovative, and solve problems better, maybe the absolute best thing you can do is just put the phone down, stare off into space, and let your amazing biological simulation engine do exactly what it was built to do.
Welcome to This Explainer. Today, we're going to completely dismantle pretty much everything you thought you knew about how your brain handles memories, and honestly, more importantly, how it handles the future. If you've ever thought your brain was simply recording your life like some sort of biological video camera, well, you're in for a massive surprise. We're looking at some truly groundbreaking neuroscience today that completely redefines what our minds are actually doing when we're just, sitting around.
So let's dive right in by pondering a really fascinating mystery. How exactly does your mind anticipate scenarios that haven't even happened yet? Because we do it literally all the time. We imagine what we're going to say in a tough meeting. We picture the exact route we'll drive to that new restaurant, or we sit there weighing the pros and cons of a huge life decision. It feels totally effortless to us, but the biological machinery actually making that possible, it's an absolute marvel.
Deep inside all that neural machinery is this little seahorse-shaped structure called the hippocampus. Now, for the longest time, the hippocampus was thought of as just a simple biological hard drive. But as you're going to see, it's actually a wildly dynamic imagination engine. It operates a lot less like a hard drive and much more like a highly strategic, high-stakes corporate board.
Let's start with Section 1, the myth of memory. We're going to look at the major paradigm shift that completely overturned a long-held scientific belief. For decades, literally the past 50 years, the dominant theory in neuroscience was that a very specific neural circuit within the hippocampus, known as CA3, was basically just a dusty filing cabinet. Scientists genuinely believed its primary job was just to record fixed, constant patterns from our past so we could, retrieve them later. The whole idea was that it was entirely about storing what had already happened. But researchers started noticing this glaring anomaly. I mean, think about it. If the hippocampus just stores memories, why does it actively generate completely new, entirely unexperienced sequences while we sleep or just rest? When scientists looked closely at brain activity during downtime, they didn't just see old memories playing on a loop. No, they saw the brain firing off complex sequences of events that hadn't even happened yet.
Which brings us to Section 2, CA3, the simulator. Let's officially meet the first half of our internal corporate board, the wild, highly creative brainstorming department.
Take a look at this incredibly dense web of connections. In the science world, these are called recurrent collateral branches, and they live inside CA3. In plain English, these neurons are heavily densely wired to talk back and forth to each other constantly. And because of all these weak overlapping connections, CA3 is uniquely susceptible to self-excitation. It doesn't even need outside input. During rest, it just randomly fires off incredibly creative patterns all on its own. So rather than just replaying the past, this circuit acts as a massive scenario simulator. Because of its chaotic, totally interconnected structure, CA3 focuses on one thing: volume and variety. It generates massive, sprawling amounts of potential future outcomes and weird combinations without you even realizing it's happening. It's essentially throwing a million different ideas at the wall just to see what sticks.
But obviously, you don't act on a million different random ideas at once, right? So, Section 3, CA can, value selector. Let's see how the second crucial circuit acts as the strict, value-driven executive board.
When researchers started investigating the CA1 circuit, which is the very next stop after CA3 in the brain's wiring, they made a stunning discovery. CA1 contains specialized neurons that are extremely sensitive to value. Like, they literally process and represent the anticipated reward of a specific outcome. This was a massive shock to the scientific community. They used to think CA1 just passively passed along memory info, but actually, CA1 acts as a ruthless curator for all those endless crazy ideas generated by CA3.
So here is the absolute crucial takeaway, the contrast between the two. CA3 simulates and generates. It is entirely about volume and variety, just dreaming up every possible path you could take. CA1, on the flip side, evaluates and selects. It's laser-focused on value and curation, essentially looking at all those wild simulations and asking, okay, but which of these actually gets us a reward?
Section 4, simulation and selection. This push and pull dynamic forms the core of an absolute game changer in neuroscience. It all comes together in two incredibly elegant steps. Step 1, the CA3 brainstorming department fires up while you're just resting or sleeping, simulating massive amounts of potential futures. Then, Step 2, the CA1 executive board filters those sequences. As CA3 pitches its wild ideas, CA1 steps in as the ultimate gatekeeper, strengthening only the neural sequences that are associated with a high value or a big reward.
Section 5, preparing for the future. So why does this internal corporate partnership actually matter for your daily life? Why are we built this way?
Well, imagine you're facing a really complex choice, kind of like navigating a literal maze. Whether that's physically finding your way through a brand new city or metaphorically navigating a really tricky career move, you need to find the best path to the reward. Thanks to simulation and selection, your brain doesn't have to figure it all out from scratch in the heat of the moment. It's actually already simulated the various routes and selected the highest reward path while you were just chilling out on the couch.
By strengthening these high-value simulated sequences well in advance, your brain ensures that you are literally pre-wired to make the best possible decisions. When you finally face these situations in real life, your neural pathways have already practiced the optimal choice. Your CA1 has primed your brain to automatically go after the highest value outcome. It's like having a cheat code for life.
So as we wrap up this explainer, I really want you to think about those quiet moments in your day. When you're just staring out the window on a bus, or taking a walk, or falling asleep, your mind isn't just idling, it is working overtime. As you sit here, right this very second, you really have to wonder, what incredible future scenarios is your CA3 generating right now, and which ones will your CA1 select to become your actual reality? Thanks so much for watching, and definitely keep exploring the incredible machinery inside your head.
Okay, let's dive right in. Welcome back to The Explainer, everyone. Today, we are looking at something that is just absolutely mind-boggling, and that is the sheer scale of human achievement. I mean, when you really stop and think about it, we share this planet with millions of other animal species, right? And all of them are driven by the exact same fundamental biological goals, survival and reproduction. But here's the catch. While most animals just adapt to their environments, we humans completely reshape ours. We build sprawling cities, we launch space stations, we develop incredibly complex technologies. So you have to wonder, what exactly gives us this massive edge? Well, today we are decoding the specific biological engine inside our heads that actually makes all of this possible. You see, every other animal out there has a brain that's fundamentally wired just to keep it alive. It's constantly processing immediate threats, looking for food, navigating the physical world. But the human brain does something entirely unique. It doesn't just react to the world exactly as it is, it actually imagines the world as it could be, and then it literally drives us to build it. It is the engine behind every massive societal structure and every single technological leap we have ever made. Which naturally leads us to the central question of our explainer today. What is the true biological engine of human innovation? Is there some specific mechanism, a specific piece of neurological hardware in there that allows humans to invent, create, and progress so incredibly fast throughout history? Well, the answer isn't magic. It's pure biology.
Let's start with Section 1, the brain's executive controller.
To really understand this, we need to introduce the main character of our story, the prefrontal cortex. I want you to think of this not just as some random piece of biological tissue, but as the ultimate CEO of your brain. If you look at the comparative size of this region across different species, the difference is just staggering. A cat, a dog, even a macaque monkey, they all have relatively small frontal areas. But the human prefrontal cortex, it is massively expanded. It's this incredible evolutionary leap in brain real estate that gave us our unique executive edge. So what exactly does the CEO do all day? Well, it handles what neuroscientists call executive functions. You can basically think of executive functions as the collective cognitive operations that manage absolutely everything else. We're talking about your working memory, your logical reasoning, your ability to plan ahead, and your emotional control. Getting a handle on this vocabulary is absolutely crucial for understanding how our neurological CEO manages the crazy complexity of the human mind. Let's break down the CEO's daily to-do list. First, it coordinates your working memory, basically keeping information online in your head so you can actually use it in the moment. It directs your logical reasoning to solve problems, it formulates long-term strategic plans, and crucially, it manages your emotional control so you don't just act on every single random impulse. Ultimately, it's making the really high-level decisions. The key takeaway here is that the prefrontal cortex doesn't just passively sit there processing basic sensory data like light or sound. Instead, it actively oversees and controls your other brain functions to make sure you achieve your internal goals.
Moving right along to Section 2, Mastering the Abstract World.
This brings us to the very first real superpower of our brain's CEO, its ability to master the abstract world. Think about how different parts of the brain work. Most areas are just processing direct sensory inputs, right? They're dealing with immediate physical reality, like seeing a tree, touching a hot stove, or hearing a loud noise. But the prefrontal cortex, it completely shifts gears. It deals with processing abstract concepts. It handles rules, theories, complex mathematics, and general knowledge that doesn't actually physically exist right in front of you. There's actually a running joke among researchers that if you stick an electrode into the prefrontal cortex, you can find a signal for almost anything you're looking for. And that's because it functions as a general-purpose control unit, not just a specialized sensory processor. It's totally unique because it pulls in and integrates information from all over the brain, combining those abstract rules with physical realities to serve whatever your current objective happens to be, rather than just automatically reacting to whatever's physically poking you.
Which brings us to Section 3. Cognitive flexibility and context.
Superpower number 2 is cognitive flexibility. Let's be real, life in a complex human society is never static. What's considered totally appropriate in a serious corporate boardroom is very, very different from what's appropriate when you're screaming in the stands at a football game. The prefrontal cortex gives us this cognitive flexibility, allowing us to seamlessly adapt our behavior dynamically based on the context of shifting environments and our shifting internal goals. It lets us read the room and switch gears smoothly, making sure our actions always line up with the unwritten rules of our daily lives. Now for Section 4, the engine of perseverance. This introduces our third and honestly perhaps the most relatable superpower. I want you to consider this question for a second. How do you work day and night for 5 years to earn a PhD? Really think about it. From a purely survival standpoint, it makes absolutely zero biological sense to exhaust yourself, lose sleep, and endure years of grueling effort for a piece of paper you literally won't even see for half a decade. So how do humans override their basic biology to actually pull this off? Well, the answer lies in an epic battle between short-term impulses and long-term goals. Your basic biology wants you to sleep, it wants you to eat, and it wants immediate comfort right now. But your prefrontal cortex steps in as the ultimate mediator. It actively suppresses those immediate impulses and desires. It's effectively standing there telling the rest of the brain, nope, we are going to stay awake and we are going to study because we have a massive multi-year achievement that we are aiming for. So the takeaway here is pretty profound. Without the prefrontal cortex, working toward a 5-year goal is, quite frankly, biologically impossible. This extreme perseverance, this incredible ability to anchor ourselves to a future that doesn't even exist yet, is uniquely 100% human, and it is driven entirely by this highly developed region coordinating our behavior toward the future. Finally, Section 5, the blueprint for innovation. This brings us right to the climax of our explainer. To truly understand how all these executive functions combine to actually create innovation, we have to introduce a super vital connection point in the brain known as the precuneus.
Think of the precuneus as a critical hub. On one side, you have your default mode network. That's the part that lights up when you're daydreaming, imagining things, and just letting your mind wander unconstrained. On the other side, you have the central executive network, managed by our CEO, the prefrontal cortex, which is all about strict evaluation and logic. The precuneus acts as the bridge. It links our wild, unconstrained imagination with our CEO's strict, logical evaluation, forming the very biological basis of creative, innovative thought. Because here's the thing, innovation isn't magic. It is a highly structured biological process. First, abstract thinking allows us to just generate brand new concepts out of thin air. Second, cognitive flexibility allows us to adapt those new concepts to messy real-world problems. And finally, perseverance gives us the grit and stamina to actually build the solution over months or even years. It's a perfect biological synergy, all managed by our executive controller. So I want you to just look around you right now. The screen you're watching this on, the building you're sitting inside of, the medical breakthroughs that keep us all healthy. Every single human invention you see is the direct result of this one specific brain region doing its job, coordinating seamlessly with the rest of your neural networks. Our entire human civilization is quite literally a product of the prefrontal cortex. Knowing that you have this incredibly powerful biological engine sitting right there behind your forehead, I'm going to leave you with this one question. What will your CEO build next? Thanks so much for joining me on this explainer. Keep learning, and I'll see you all next time.
Welcome to This Explainer. Today, we're diving into what is honestly the ultimate mystery of human exceptionalism. I mean, have you ever stopped and really wondered how we, out of the millions of species on Earth, ended up as the ultimate innovating species? We are going to decode the biological and cognitive secrets behind human imagination and figure out exactly how we built the modern world. Take a quick look at the technology around you. The device you're watching this on right now, the architecture outside your window, the medical science that keeps us alive. Now ask yourself a fairly profound question. Why are humans, who are biologically so incredibly similar to other primates, the only creatures building complex computers, writing laws, and launching rockets? Lots of animals are perfectly adapted to their environments, sure, but we're the only ones who actively reshape our environment using high-level, abstract ideas. For thousands of years after the dawn of basic agriculture and early tools, human innovation moved at an absolute crawl, just slow and steady. But then, as we hit the modern era, going from the steam engine to the automobile, mapping the human genome, landing on the moon, our progress just explodes. It's this massive vertical spike on an exponential curve, a complete explosion in both population and technological mastery. We didn't just keep adapting, we literally learned to invent on a massive, unprecedented scale. So, how did we pull this off? To really understand this explosive growth, we can't just look at the tools we made. We have to look inward. Think of the human brain as a biological supercomputer. At some crucial point in our evolutionary history, this computer got a major, unprecedented hardware upgrade. But it wasn't just the hardware. It was combined with the ultimate networking software. And it's the fusion of those two exact elements that completely unlocked our capacity to innovate.
Our brain is this beautifully complex organ. For decades, neuroscience really just focused on how it processes sensory data from the outside world, managing our basic survival and motor functions. But the real magic? That happens when we look at how this physical hardware manages our internal world. It runs our highest levels of abstract imagination, giving us the power to visualize things that literally do not exist yet. Enter the precuneus. Historically and linguistically, this region carries some profound meanings. For example, it's sometimes referred to as al-talal in Arabic, which beautifully echoes this idea of looking at the remains or the very foundations of thought. Throughout our evolution, this specific area underwent a massive expansion. The precuneus is essentially the physical engine for our internal thought. It's the foundation that lets you hold high-level abstract concepts right in your mind's eye. Without this upgraded hardware, we simply wouldn't have the processing power to imagine a new tool, conceptualize a mathematical vector, or invent a justice system.
Here is the wild part. You probably think your brain is working its absolute hardest when you're furiously typing an email or solving a tough puzzle. Actually, scratch that. The default mode network, which the precuneus is a massive part of, kicks into high gear when you're just staring out a window or lying in a hammock. During those quiet moments of rest, this network is busy simulating future scenarios and mashing up abstract concepts. So hey, next time someone catches you daydreaming, just tell them your biological hardware is doing the vital work of creative innovation.
But hold on, there's a huge catch here. Even the absolute most powerful biological hardware is severely limited if it's operating totally offline. Imagine an early human whose precuneus fires up with the perfect blueprint for a revolutionary new hunting trap. If they have zero way to communicate that abstract idea to the rest of their tribe, well, the invention dies the second they do. The greatest hardware in the world is completely useless without a network to share the data.
Now, there is a massive gulf between animal communication and human language. Animals absolutely communicate, right? Bees do their waggle dance for pollen, monkeys sound alarms for predators. But that communication is largely tied to immediate, localized needs. Human language, on the other hand, is a completely different operating system. It allows for infinite combinations of symbols to express high-level abstract ideas. It literally allows for mental time travel. We can discuss what happened a century ago or debate what we're going to build 10 years from now.
And that software lives right here, in specialized regions of the brain like Broca's and Wernicke's areas. These centers are the exact networking protocol our minds needed. They made it possible for the incredible abstract imaginations generated by one person's precuneus to be perfectly encoded and then transmitted directly into the brain of someone else.
Oscar Wilde actually hit the nail on the head when he said, "Language is the parent and not the child of thought." It's a philosophical insight, but it beautifully captures exactly what modern neuroscience is discovering. We tend to think of language just as a tool for outputting thoughts we've already formed, but it goes way deeper than that. Language provides the actual architecture that allows complex abstract thought to exist in the first place. I want you to think of language as mental scaffolding. Just like physical scaffolding lets construction workers build a skyscraper way higher than they could ever reach on their own, linguistic scaffolding allows our biological hardware to reach so much deeper into abstract realms. It helps us build incredibly complex mental structures, conceptualize algorithms, and organize whole societies in ways that just wouldn't be possible without the words to anchor those concepts.
Which brings us to this brilliant realization by the philosopher Ludwig Wittgenstein: the limits of my language mean the limits of my world. Words for abstract concepts aren't just convenient labels. They are vital cognitive tools. Every time we learn language, we're actively expanding the boundaries of what our individual minds can even conceptualize. The more robust our language, the more incredibly powerful our capacity for abstract imagination becomes.
Okay, let's put the whole puzzle together. How does this ultimate innovation engine actually run? Step 1. The expanded hardware of the precuneus, our talal, generates the abstract idea. Step 2. Language steps in and encodes that idea into a structured format. Step 3. Communication transmits that encoded idea from one brain to the next. And finally, Step 4. The real game changer, intergenerational stacking. Ideas don't just spread, they pool together into this massive, shared reservoir of human knowledge. By networking our brains together through language, we're basically creating a generational supercomputer. This is the whole shebang. This is what truly separates us from every other species on the planet. It lets us completely bypass the limits of a single human lifespan. Thanks to high-fidelity knowledge transfer, inventions just keep accumulating over centuries. Someone invents the wheel, generations pass, someone else invents an engine, and because of our unique drive to collaborate, our shared intentionality, we eventually combine them into a car. Everything we have is stacked upon the successes of everyone who came before us. So our biology gifted us the remarkable hardware of the precuneus, and language gave us the ultimate networking software to connect those brains across time and space. Right now, literally, at this very second, your own brain is processing the language in this explainer to absorb concepts that took scientists decades to uncover. As our generational supercomputer keeps growing stronger and more connected, what impossibilities are our connected minds going to conquer tomorrow?
Welcome to This Explainer. Today, we're embarking on a fascinating journey to explore the biological mechanics behind our very best ideas. We're going to break down the exact science of human creativity, figure out how it ticks, and, most importantly, learn how we can harness it. Let's get right into it. Okay, let's dive into this. We're talking about the 3-pound engine that quite literally drives all of human civilization, the brain. I mean, sure, insects might outnumber us 1 billion to 1, but we humans have totally dominated the globe in a completely unique way. And why is that? Because we're essentially Homo innovaticus. We're a species that is uniquely driven and biologically hardwired to invent, adapt, and just completely transform our environment. But, this brings up a massive question. Where do our best ideas actually come from? Seriously, think about it. Is creativity just random luck? Just some magical spark that hits you out of nowhere? Or is there a physical, biological process happening right there behind your eyes? Well, today we're going to look under the hood of the brain to find the exact answer to that question. Here is our roadmap for today. We'll start with the roots of human innovation, then we'll look at the 2 paths to creative genius. Next up, we'll cover the power of idle minds and finding your state of flow, before we finally cast our eyes to the future with AI and the innovation horizon. All right, Section 1, the roots of human innovation.
Think about how we transitioned from primitive survival to building these massive, technologically advanced civilizations. If you look at human history, there's this incredibly long, almost entirely flat line stretching across millennia. For the vast majority of our history, population and technological progress basically didn't move. But then, boom, suddenly an exponential spike, driven by massive shifts, from the agricultural revolution to the industrial revolution, right up to mapping the human genome. And this incredible acceleration, it's entirely driven by our unique cognitive ability to imagine really high-level abstract concepts. We don't just react to the world around us. We mentally simulate things that don't even exist yet.
And this famous quote really hits the nail on the head. As Einstein pointed out, logic will get you strictly from point A to point B. But imagination, our brain's ability to use high-level abstraction, to combine existing knowledge into completely new ideas, that takes us everywhere. It is the absolute core ingredient of all revolutionary technology.
Moving right along to Section 2, 2 paths to creative genius.
Okay, so we really need to debunk a common myth here. A lot of us think of creativity as this lone genius hunched over a desk, furiously working away. But true creativity, it's actually a pendulum, swinging back and forth between 2 very different neural states. On one side, we have spontaneous creativity, which is governed by what we call the default mode network. Surprisingly, this network becomes highly active when we're at rest, basically allowing our minds to wander and generate wild, free-flowing ideas. But on the flip side, we have deliberate creativity, driven by the central executive network. This is the network that fires up when we really lock in and focus, allowing us to evaluate, refine, and actually execute those wild ideas. True genius absolutely requires a dynamic interplay between both of these states.
Let's ground this in a little bit of brain anatomy. Regions like the parietal cortex and the precuneus work together with the hippocampus, which is deeply, deeply involved in your memory. During spontaneous thought, the hippocampus pulls up past memories, and these other brain regions combine them in totally novel ways to build complex simulations of the future. It's wild to think about, but your brain is literally mixing the past to invent the future.
Which brings us to Section 3, the power of idle minds. So now that we know about the default mode network, how do we practically optimize our brain's spontaneous creativity in our day-to-day lives? Well, I really want you to remember these highly actionable takeaways. The 3 B's of spontaneous creativity: bed, bath, and bus. I mean, why do so many eureka moments happen in the shower, or right as you're drifting off to sleep, or just staring out the window of a train? It's because stepping away from active problem solving actively turns off your central executive network and fires up that default mode network. This lets your brain freely associate without any boundaries, effortlessly connecting ideas to deliver those sudden brilliant flashes of insight.
But there is a catch here, and it brings us to a really vital point. Your imagination is bound by your memory. Because your brain creates new ideas by stitching together existing memories and experiences, you literally cannot imagine with ingredients you don't possess. So to be truly innovative, you have to constantly broaden your horizons. Read widely, experience diverse cultures, learn about subjects way outside your normal profession. These diverse experiences are the raw fuel you need for spontaneous innovation. All right, let's jump into Section 4, finding your state of flow.
Now we're going to swing that pendulum right back from total relaxation to intense, deliberate focus. Because let's be real, an idea is only as good as our ability to actually execute it. So the crucial point is understanding flow. Flow is a state of such intense, immersive focus on a complex task that your self-awareness literally fades away and your perception of time completely distorts. When you enter a state of flow, you fully engage that central executive network. All your neural pathways align to tackle a specific, difficult challenge, completely blocking out all external distractions.
A classic and honestly kind of hilarious example of this is Archimedes. He was tasked with determining if a king's crown was pure gold without damaging it, and he struggled immensely with it. The actual breakthrough came when he took a bath, right? Engaging his spontaneous creativity. But he was in such a deep state of flow regarding this physics problem that when he finally solved it by observing water displacement, he famously jumped right out and ran naked through the streets of Syracuse, shouting, "Eureka!" Now, that is the raw power of mixing spontaneous insight with an intense state of flow. And finally, Section 5, AI and the Innovation Horizon. We've talked pretty deeply about our biological brains today, but here's a provocative question for you. Will artificial intelligence outpace human creativity? It's a huge question. For a long time, we just assumed AI would only ever handle rigid logic, while art and imagination would remain strictly human territory. But today, machine learning algorithms are actually beginning to mimic the very cognitive, abstract functions that make us Homo innovaticus in the first place. To put that into perspective, modern deep learning systems now utilize over 100 layers in their artificial neural networks. 100. That depth vastly exceeds the layer architecture of our own biological brains. And while our biology relies on really slow evolutionary changes across generations, these digital networks can iterate, evolve, and essentially clone themselves almost instantly. And that incredible depth allows AI to take action in some truly astonishing ways today. It's writing original poetry in mere seconds. Through reinforcement learning, where the AI is basically driven to maximize a reward, systems built by cutting-edge companies have successfully reduced massive data center cooling costs by a staggering 40%. They're solving complex environmental puzzles that totally baffled human engineers. AI is mastering highly abstract, strategic environments at speeds we can honestly hardly comprehend. This exponential growth is charting a pretty startling path. We've gone from the Industrial Revolution in the 1850s to our current deep learning era, leading us toward the year 2045. That's the year many futurists predict will hit the technological singularity, a point where artificial intelligence creates a runaway intelligence explosion, and technological growth becomes completely autonomous, irreversible, and incomprehensibly fast. So as we wrap up this explainer, we're really left with a lingering thought. Have our incredible biological brains, the exact same brains that gave us fire, agriculture, and the moon landing, now created the ultimate tool to solve global crises like climate change? Or have we actually engineered the very mechanism of our own obsolescence? The pendulum of human creativity has swung us into an entirely new era, and it's up to us to decide where it lands next. Thank you so much for joining me on this explainer. Keep exploring, keep questioning, and whatever you do, keep broadening those horizons.